Hello everyone. In this video I'll review kind of everything we need to know before we jump into lab next week, week 2. So for this week we are only meeting for recitation. We are not meeting for lab this week. So this recording is for the online section. Please come to the in-person, or the in-person labs should come to the online recitation on Wednesday. So some basics we need to talk about today. We'll do a brief introduction to what to expect in this lab. We'll talk a little bit about expectations of mine and some etiquette. And we'll talk about some new stuff for Chem 2260. So let's start with some expectations. In my classroom, I focus on being really motivated to learn, not focusing on memorization. Memorization isn't so important, but really just focusing on diving down into the material. Additionally, I always really focus on communication. Communication is really important for setting expectations. So if you're going to miss lab, if you think you need to turn in an assignment late, for example, please just let me know. And then this will help me reset my expectations, will help me be flexible, and will help me accommodate you. This is definitely my preference. I really don't like it when students miss class or miss an assignment without telling me first. I know it sometimes happens, but to kind of work in our professionalism, it's best to communicate ahead of time. Additionally, come to my office hours. I love having students in my office hours. I have office hours Monday, Wednesdays at 1 o'clock, or Tuesdays, I believe, at 10 a.m. Please sign up via my Calendly link. I'm happy to meet with all of y'all. The Monday appointments are optionally in person, so if you want to meet me in person, let's meet on Monday. And then lastly, folks, the best learning comes from making mistakes. So my classroom is a place where mistakes are okay. We don't have to be perfect together. We'll learn from our mistakes. Additionally, throughout the semester, since we are still in the middle of a pandemic, surprise, we're going to keep the same groups each week. This will help with contact tracing if the need arises. Additionally, folks, I want to emphasize at this point for the in-person section that we will be masked all semester. So please be prepared to wear a mask and wear it properly. We need to be wearing masks that kind of fit our face snugly across the nose, the cheeks, and the chin. Additionally, we need to make sure that both our nose and our mouths are covered at all time. On the first day of class on Wednesday, next Wednesday, so week 2 Wednesday, we'll get to know each other a little bit within our groups, and hopefully the online folks can get to know one another a little bit. Just for everyone's knowledge, our TA Zana will be helping with the online section. She'll be recording what's happening in lab for y'all, and she'll be there to help answer your questions in the chat. Come grab me if you have additional questions. She'll kind of be the go-between for you as you join us virtually. A quick word on plagiarism at this point. The primary thing that you'll be doing in terms of writing in this class is writing in your lab notebook. I have a bunch of resources for that up in Blackboard that you should check out, rubrics, and really anything you need. And while I understand you work in groups and probably collaborate with these lab notebooks, I want to make sure that we're doing collaboration, not copying. So anything that's written in your notebook, particularly, your conclusions, your answers to post-lab questions, should be written in your own words. I don't want to deal with plagiarism. It's my least favorite thing. It's your least favorite thing. It's a waste of time for everyone, right? So what exactly is plagiarism, right? Copying straight from a friend. You shouldn't be copying straight from a friend. Additionally, and this one's a little more subtle, you shouldn't be copying straight from myself either. I provide you the materials, and it's your job to kind of reframe those materials in your own words. Additionally, if you find something online, just make sure to rephrase it in your own words. Anything that you turn into me, you should be able to explain to me and defend. And if anything's ever unclear, you're not really sure what constitutes plagiarism, come talk to me. I'm happy to talk to everyone. Now let's get down to the business of what's going to happen in this class. So, for the first 10 weeks of class, starting in week 2, we'll be doing a reaction every single week. Additionally, for these weeks, we'll follow up with a weekly quiz. Next week's quiz will be on what kind of we're talking today about. And so it's just kind of basic stuff. By doing the reactions in class, by asking questions in lab, you should be prepared to take the quiz. These things you should kind of learn as you do them. Additionally, you'll see that towards the end of this semester, we have final projects that we'll be working on. These final projects should be an opportunity for you to do a little bit of fun kind of research to really connect how organic chemistry impacts the real world. More on that to come later. So, what can we expect? Since we're still in a pandemic, my preference is to kind of cut down on the flow of paper between us. So your assignments should be turned in on Blackboard. Starting next week, I'll have some asynchronous materials for you to do before we come to lab on Wednesday. So there'll be a recitation video that you'll want to watch. There'll be a quiz you'll want to take. All of those things you can do at any point before next Wednesday. Additionally, before you come to lab next Wednesday, I want you to submit your pre-lab to Blackboard. If you're wondering about expectations for lab notebooks, please check out the rubrics that I have on Blackboard. I highly recommend using a phone app called Cam Scanner. You can take a picture of your lab notebook pages with your phone. It'll convert it to a PDF and make it really simple for you to upload them into Blackboard. And so these pre-labs are going to be due at midnight the day before lab, so that's going to be midnight Wednesday, technically Wednesday early morning. Once your pre-lab's in, midnight Wednesday, come into lab in person or join us virtually online. If you're coming in person, you need a mask, you need safety goggles, and a notebook. If you're joining us online, you really just need a notebook to take your notes. Additionally, for folks online, we will be providing you with some supplementary lab notebook pages from folks who have joined in person, so you have all that data. What about after lab? Again, you can work to finish up writing your lab notebook pages throughout the rest of the week. They'll be turned in and due before the next class. So that means that the next Wednesday, midnight, your post-lab notebook pages will be due. The post-lab includes, the notebook pages themselves and some new things, a green chemistry worksheet and an analytical data sheet where we go over some spectra. Let's talk a little bit about some graded elements in this class. Your notebook pages are really the bulk of what I'm looking for in this class. Can you maintain a good professional lab notebook? If you're interested in how these will be graded, please check the rubrics online. There will be weekly quizzes for the first 11 weeks or so, 10 total, and I will drop one lowest quiz. These quizzes are open notes, and you can kind of take them whenever is okay for you to take it before class on Wednesday. We have a final project. As I mentioned, in this final project, you'll be assigned a group of organic molecules, and you'll present to us about their history and their impact. And we'll follow those final projects up with a final reflection, and that will kind of be the end of the course there. No final exam, just a final project. So what are some things that are new that you should be prepared for? Well, probably the thing that might be new is submitting your notebook pages online. That's just to cut down on paper changing hands. We want to kind of limit the exposure because we're still in a pandemic. Pre-lab will be due on Blackboard midnight Wednesday, so that's midnight before lab. And the post-lab will be due the following Wednesday, midnight. Now, two new things are the analytical data sheets and green chemistry calculations. After each experiment, you'll have a set of analytical data sheets and green chem worksheets. In the analytical data sheets, you'll be given the structure of the product you were supposed to make, and you'll be given a series of spectra. So you'll be given the proton and the carbon NMR spectra. And what we want you to do is kind of assign the various NMR peaks to the atoms in the product. There are a bunch of helpful tools on Blackboard for you, some NMR tables, and one additional NMR table that is particularly good for assigning peaks to benzene ring carbons and hydrogens. There'll also normally be an IR spectra for you. Again, there's a table up on Blackboard. These shouldn't be things that you need to memorize for this class. You can work from a table, because that's what I do. And then finally, there'll also be a mass spectrometry graph. This might be new for most of us, so we'll cover that next week in the asynchronous recitation. For now, let's focus on the thing that's probably most new. In Organic 1, you probably covered NMR. Review that on your own if you want, and or use the tables provided. The newest thing is probably these green chemistry worksheets. So an important learning outcome of this class is understanding more about green chemistry. The American Chemical Society really focuses on green chemistry as one of their learning outcomes. And it kind of helps us as scientists connect the impact of the reactions we do to the planet Earth. Are we being wasteful? Are we using chemicals that are super hazardous or not, etc.? Now, as a part of these worksheets, there are some things that you're probably familiar with, right? Theoretical yield is on there. Percent yield is on there. These should not be new. If you have any questions about them, feel free to come to me. What is new is probably the rest of the stuff here on this slide. Something called a percent atom economy, something called a percent experimental atom economy, and overall greenness. So let's talk about those before you do your first worksheet. Percent atom economy. At this point, folks, I want to just make sure that you know that in Blackboard, there's a green chemistry worksheet. There's a document that has kind of explanations for the worksheet. And additionally, I have an example worksheet up there for you so you can kind of see how I went through the math. Percent atom economy focuses on kind of literally what percent of atoms in the reactant end up in the product. When I do this, I really prefer to draw it out because the visualization makes a lot more sense to me. So for example, here's one reactant, and then the second reactant is under the arrow. We ask ourselves, what atoms in these reactants are in the products? So as you can see here, I've kind of highlighted the different atoms. This whole section came from this reactant, and this section here came from this reactant. You can see all of those atoms ended up in product, but then of course, some of these atoms here did not end up in product. You literally count the atoms and use their atomic mass to figure out percentages. So you kind of say, ooh, there's 7 carbons utilized, there's 3 oxygens utilized, there's 5 hydrogens utilized that all come from salicylic acid. But there is 1 hydrogen in salicylic acid that is unused, does not end up in product. This is kind of how we start calculating percent atom economy. Talking about percent of actual atoms. Slightly different is percent experimental atom economy. The experimental there is meant to kind of show you Like, what are the actual masses of stuff that you used that ended up in product? Okay? So what % of the mass of atoms that you actually measured out ended up in the product? And so at this point, we need to make sure that we have really good note-taking skills, that we wrote down the mass of stuff we measured in lab. For example, right, if I massed out 1.4 grams of salicylic acid, and I know based on my previous calculation that like almost all of these atoms are used, right? If we look back real quick, all of these atoms are used, and the only thing that wasn't used is a hydrogen. That means that in terms of this reactant, it was basically 100% used, but that won't be true for all reactants. So % experimental atom economy, we're talking about what portion of the mass of reactants that you measured out ended up in product. Finally, overall greenness, this kind of is a big picture. How green was the reaction? Technically, it's % yield times experimental atom economy, but if you look at the worksheet, it simplifies out really nicely to actual yield over total mass of all reactants. And definitely check out my example worksheet if you want to know more. So over the course of the next couple of weeks we have together, we'll talk about all the principles of green chemistry. I've listed them here on this slide and on the next slide as well. Don't worry about memorizing these at this point. We'll talk about them in the coming weeks. I look forward to going into more depth about them. Finally, folks, from here on out, recitations are asynchronous. Next Wednesday, for the first time, we'll come to lab in person, 5:30 p.m. Eastern Time. Either join us in person or online. And then quiz 1, which will be due before next Wednesday, will be about what we discussed just now. And I will leave you finally with a cat meme. See you guys on Wednesday.